to move in a complete circle. From their source through resisting electrical devices and back to the source. So let's look at some of these words here. Pathway. That's commonly made out of what type of material?
Copper.
Copper. Very good. Where's the source?
Power plant.
The power plant or a? Well, this is connected to the power plant. Alternating current. A battery, huh? Okay. What's resisting electrical devices? Is a what?
Computer, laundry machine.
Toaster, microwave, and let's get modern. Instapot. What's the other one? That's the rage.
Air fryer.
Air fryer.
Tesla.
Tesla. It's good. And you need to know this. In order for all this to work, you have to have an excess of charge at one end. And that would be, for the wall, that would be where? Where would you have an excess of charge when we're talking about a wall outlet? We already talked about it. The power plant, right? And that is there, that scenario is there, whether it's you plug anything in or not. It's still an excess at one end. And on a battery, where would it be? One of two.
On the negative part of the truck.
You ever jump a car? Okay, and you got to make sure you do what?
Do not put them on the wrong spot.
Okay, negative to negative, positive to positive. So on a battery, it's the negative pole is where the excess charge is. Okay, let's talk about something called current flow. Current flow refers to the quantity or the number of electrons flowing. What's the unit for current?
Voltage.
We're guessing, but it's okay. We'll get there.
Hertz.
Ampere.
Amperes, amps. What? Somebody stole your thunder.
You did.
Oh.
Sorry.
Does she?
I won't do it again, I promise.
Well, Asia, you've been heard. How about that? Okay. An ampere. This is the amount of current flowing. So in other words, as you turn on more electric devices, You're pulling more what? You're pulling more amps. You're asking for a greater flow of current. And we can even break this down more. In other words, how do we measure this? It would be an electron passing a point. So if you turn on a bunch of appliances, you're pulling a lot of electrons past a point. And the more of this that occurs, and your devices start to use these electrons to function, what's the byproduct? Close. What's the byproduct? Heat. Yeah. Too much heat, what happens? Yeah, or you shut down. Yeah. Okay. So keep that in mind. Current flow past a point, electrons. The next one.
One of the houses in my neighborhood just caught on fire. It's a brand new house
Was that on the news?
in Rivertown. We just bought a house in January, and then these people just moved into their house down the road. And then it
What's
caught
the
on
story behind it? Do you have any?
fire. The builder left the vent cap on the dryer thing, and they did it to us too because I called out a dryer came to check ours because my daughter's room is right next to the laundry room, and they left the vent cap on ours too. But my dryer is a smart dryer, and it shuts off if it's overheated. But theirs wasn't, and they had two kids upstairs, and the cats were jumping out the second story window and stuff like that.
You know, now that you brought it up, I'll share a story that we went through not a couple of years ago with a dryer. It was a regular weekday night. The dryer was running, and it started making a horrible sound. Went to it, tried to start it again, wouldn't start. Oh boy. So, it wasn't that old. Pull out the warranty, make a call, get in line for service. In the meantime, what do you do with your clothes? You take it to you ever heard of this, a fluff and fold? A place where they do laundry, and they'll fold it for you and all that. So, why is this dryer broken? A couple days later, I knew why. There was an odor coming from the dryer. I knew what it was.
There was an animal in your vent. Oh my god.
Yeah. Mm-hmm.
My friend,
So,
when I would open it, it would hit you with the stench of smoke.
oh
So
sure.
I was like, something's wrong. There's something wrong.
So, I pulled it away from the wall and looked in the port on, for each, the wall in the unit. Yeah, there it was. It was a chewed up snake.
Oh, wow.
Mm-hmm. So with warranty, if you take the back of that dryer off, it's over. They don't want to hear that. We didn't. But this isn't a defective part. This is on us. So this was on us. So we took the dryer to the garage because of the smell.
That's crazy.
Pardon me?
So that's crazy.
And what did we have to do in the end? What do you think we did?
Left the
New
snake.
dryer.
Oh,
We had to get a new dryer.
That
It's got that
sucks.
odor in it. Who wants it?
yeah.
So they're
Somebody.
gonna smell like that too.
With the guy who came out to do service, and he said, "This isn't on us. This isn't something that we're liable for." And he was right. So my point here is, guys, on your outside vent, not be a bad idea to have a little screen over that. And I've lived in this house for a while. April is when I start to see a lot of what?
Snakes.
And because they're mating.
Oh.
Yeah, just seeing it every spring, you see more. All right. See, this started from appliances to dryers and heat. All right, so we're on.
That's where I was coming
All
from.
right, so let's move to another one. And we're going to call this the force the speed with which the electrons travel. If you remember, amps was amount. This is the speed, the push, the pop. It's referred to as potential difference, or what's another name? You said it already.
I did.
Yeah.
Voltage.
Voltage. I mean, there's some big pop there. And did I draw for you high voltage wires yet? No?
You drew power
Yeah, you
lines
did.
at one
Yeah,
point.
That's it. Yeah, those power lines that you see, out in the field and all that, they're big structures. What do they call them? High voltage power lines. Because it's coming from the plant and it's got some voltage. It's got a lot of, and it's incredible. Birds sit on them. They seem to be okay.
High voltage, low amperage, or what?
Oh yeah, they can control it at the plant by they can decide we're going to transmit this as high voltage, low amperage, because if they did it the other way around, the plant transmitted high amperage, low voltage, what would be lost? What's a lot of amperage do? It creates, we just talked about it, heat, okay? Associate these two words. When you see potential difference, think of voltage. This is the force. The unit is a volt. And just a little side thing here, to make x-rays, we need high voltage. We need high voltage. And we've got one more thing to reckon with here. Opposition. What's another word for that? That kind of, we're leading into the study of electricity. Opposition, or how about resistance? What's the unit for resistance? Okay. 3-letter word. You heard of it.
Ohm.
Ohm.
I said it first, Mallory. I'm kidding.
It's okay.
I was here. All right, so the unit is, or resistance is ohm. It's that's the symbol for ohm. All right, key components for a circuit. Okay, let's talk about some factors that affect current flow in a conductor. And that is, we need a material that conducts and moves electrons. All right, so the first one is material. The ability to conduct electrons. Now, another item that affects current flow is the length of, we'll call for this purpose, just the length of the conductor or the circuit, length of the circuit. Now, there's a relationship between current flow and length. Anybody want to throw it out? Okay, let's take away fast.
Frequency.
No, you're getting too fast. But you're standing on third base.
Okay. The shorter the circuit, the shorter the current flow. I don't know.
All right, let me clean this up. Thank you. Very good. I'll give it to you this way. Length, an increase in length of a circuit increases resistance. Why?
They're directly proportional.
They are. There's more there, isn't there? There's more wire to push through. And you were saying shorter, the least.
Yeah.
Right? Now, what about, and let's just look at a circuit. The diameter of this wire. What's the relationship there to current flow? Small, large. Huh? The greater the diameter, the less resistance. Okay, what more flows, right? A nice way to picture this is just think of this, of a garden hose. Compare a garden hose to a fire hose, right? You got that big fire hose, it's gonna flow, right? All right. And one last component here on things that affect current flow. As temperature of the conductor increases, what do you think happens to resistance? Greater resistance.
So they're all directly proportional besides diameter.
They're pretty much, aren't they? Uh-huh. Good observation. All righty. So, I'm going to give you a problem that's going to involve these. So let's do a problem. Let me put some units up here now. We have a circuit, and what you're going to see here, I'm going to give you two, you got to solve for the third. Okay? All right, so we have 5 amps. 20 volts. What's the ohms? And I'll give you, that's problem number 1. That's problem number 2. And I'll make the third one. What's the amps? 60 volts. And all right, so there's 3 problems. And you know what? You can work as a small group. You can go to your, go online, see if you can get the answers to these. Twelve amps. Anybody else? You're all getting the same thing? I don't know. I just made those up.
Oh.
Couldn't you tell? Did you find anything online?
Yeah.
What did you see online?
I saw volts equals amps times ohm. Amps equals volts divided by ohm. And ohm equals volts divided by amp.
All right. Anybody else?
I just use one formula and switched around.
What's that?
The resistance equals the force times the current. So then I would just like look at what's there and figure out what the missing one is.
Okay.
Yeah.
Anybody else? All right. So I'm gonna put something up in your internet search. Did anybody come across something that looks like this?
Triangle.
I guess the answer is yes. Huh? Anybody else find it? Here.
I actually learned that in tech school.
Oh, you did?
Yeah. I forgot about it, so.
See, our
yeah,
tax
there's that.
dollars were put to good use.
Yeah.
All right, so give it to me. Well, first.
Amp is on the top.
Oh, why is it?
Maybe I'm wrong. I don't know. I told you I forgot. You gotta see it. Volt is on the top.
Why is it?
I'm guessing at
Sure?
this point. No. I know ohms is the bottom right. Ohm is the bottom right. It's the only one that I know for
But
sure.
The one I found is.
Then what's here?
Amp.
I.
I for amps. Now, use that and go back and check your answers. So you guys need to do this. Did you go through these programs? I know you're in your 2nd semester, right? You need to ask your professor on this stuff. Is there a formula for this?
I is amp and R is ohm. Resistance ohm.
Yeah.
Okay.
Mm-hmm. See?
I just have to remember.
So have you guys checked your work? So did VIR work, or are you still doing it? Still doing it?
Oh, I think I checked mine. I think I'm good. That's what I got.
It worked? Asia? Okay. How about on this side of the room? All right, good. So where do you think you're gonna see this stuff?
You should ask us the formula and then ask us to do it. So that the formula's in front of our face.
Well,
I'm kidding.
don't you know, here's how you do this. When you get exams that require this, because students will say to me, can we bring a cheat sheet of formulas with us? No. But what do you do when it's a paper and pencil test? What do you do?
Write it down.
As soon as I hand you the test, what do? You flip it over and do what? Write out your formulas. Then it's just a matter of knowing the problem, which formula to use, and setting the numbers up correctly. Okay? All right. Good. And in these problems, that triangle, it's referred to as Ohm's law. All righty, so something I want to talk about, and that is power. What's the unit of power? This is something you see when you read your electric bill.
Would it be
If you look at your electric bill closely, they're going to give you units of
Hertz?
power.
Watts.
Watts, or maybe written as kilowatts. And the formula for watts, amps times volts. And this is buildings have wattage safety standards. When these watts get a little too high, we get the what? Overload, and things shut down.
Watts equals amps times volts.
Amps times volts. All right, so I'm going to draw a couple circuits. We'll talk about it.
probably class? I don't know. High school?
My drawing is leaving me. You know what I'm drawing here, right? Resistors, right? All right, let's talk about A and B. Okay, any first impressions on what A is?
The circuit.
It's a circuit, okay, good. What kind of circuit? Have you heard of the two types?
Well, that one seems to have more ohms in it.
Yeah, they're just there to show resistance. Do they look different?
Yeah, this one's direct circuit.
You're trying. All right, so let's leave. A is something called a series circuit. And you guys have all dealt with where we're going to go. We're going to talk about a series circuit. First of all, let's look, are the power sources different?
Yes.
Okay. Do you know what the symbols stand for? Hmm?
So I'm trying to look it up.
All right. We'll go to B first. That's the symbol for alternating current. All right? Have I drawn the curve? The
Yeah.
sine wave?
Yeah.
Yeah, there it is. Alternating current. So what's the other one? Symbol
Yeah.
for a what?
Direct current.
Where you get what? What gives you direct current? Battery. That's the symbol for battery. So let me kind of lead you to identify a series circuit and where you've all dealt with a series circuit. An example. It's the prime example of what a series circuit is. Anybody want to answer before I take you down the journey? Series circuit? Okay. Let's go back to 2020. At the end of every year, we celebrate a couple holidays, don't we? What are they?
Thanksgiving, Christmas. I guess at the very end.
New
New
Year's.
Year's.
So let's talk about the middle one that you gave me, and that's what? Christmas. And what do we do in our homes at Christmas? We decorate, right? And what about these Christmas lights that you put on a tree?
Have one input and one output.
Well, you plug them in, right?
And then you connect them together.
Yeah. And do they always come on?
No.
Why?
Some of them die.
What happens if you break a bulb in your Christmas tree lights?
It takes out the signal.
They're all gone, right?
We changed that.
That's a series circuit. Okay? If you break a bulb or one falls out, guess what? It breaks the flow. Nothing happens because it's a
Series.
series circuit. You've all probably experienced that. It's so frustrating. Or if you look at the lights, all the lights are there.
Except for one is not on.
One is what?
Off, and then the rest of them are off. That's so funny because I was twisting every single one.
It's loose. It's loose and you broke conductivity. Let's look at B now. So A is a series. Any more questions on series? Simple circuit. B is a what then? All right, it came to you. This is called a parallel circuit. Where do you find that?
Would it just be like your regular lights?
which is found in your
House?
house is wired in parallel. Okay? Yes. Okay, so let's look at just some of these resistors here and just kind of let's just talk about these. Hair dryer, coffee maker, microwave, stove, furnace. Okay, and if one gets knocked out, do things still work?
Yeah.
They do, don't they? Because they find other ways to flow. Current's still going to make this trip. Watch. Current's still going to make this trip. Right? Current's still going to make this trip. All those things will work because it's wired in. It's a parallel circuit. Okay? Compared to the series. All right, good job with that. All right, let's review. You guys ready? Yeah, I could sit here and talk about it, or you guys could ask me questions. You could look your notes over and ask me questions. No?
This is like one on the test. What's your question?
All right, know the material from last week when we talked about what? Electrification, friction, induction,
Electrostatic.
all of that. Mm-hmm. The laws of electrostatics.
Three methods of electrification.
There you go. Mm-hmm. Know your units for what? Current is what? Current is, what's the unit for current?
Amps.
What's the current for voltage? Or volts? What's the current for resistance? Ohms. What's the unit? All right, good. What's the unit for power? Good. Know the formulas. Get your hands around what resistance. Am I going too fast? Get your hands around what resistance is. Insulators. What do?
Stop electricity.
That's right. They inhibit the movement.
Electron.
What word do you associate with potential difference?
Speed.
Volts.
Volt.
Get your hands around, we talked about earlier, characteristics of a circuit. Remember, length, material, diameter. Get your hands around those relationships. And the laws of electrostatics. Can anybody tell me what one of them is? This was on the front end of last week.
like charges repel and like charges.
There you go, like charges repel, unlike charges what? Okay, give me another one. The what? The inverse square law comes into play here with charges. Yes.
Concentration. Surface point.
Concentration on the curved surface, okay. I think you guys are prepared for that exam. We'll do next week on the front end.
Can you tell us what the answer to number 23 was? Even though you took it out.
You know, I don't know that I can because I think it's poorly written.
I don't know.
And you guys have a problem with that, right?
Mhm. Because the max amount you can have is that LCO date.
All right. Okay, an atomic number of 22 means it has 22 what? Protons. How many electrons in the second principal quantum number level is in the L shell? Well, L is the second shell, right? 2 times n squared? 8, right? You see 8 as an answer? Say that was it. So I guess it was a good question. I had a what? Lapse in the right answer.
So 10 is close.
I put 6 because the max is 8, and 6 was the closest.
I put 10 because maybe for some reason it factored in the first and second shells.
No, they never go down that road.
I know, I wrote the equation next to it, and I was like,
not right.
I don't know. Like, maybe I'm
Okay.
wrong. Maybe it's
But
wrong.
again, you guys are interested. Anything else on where we are? How are these projects coming? Are you finding material? Okay, did I talk a little bit about your method of delivery? What did I stress?
You said, don't just sit there and stare at the screen.
Don't sit there and read the screen. We can all do that. Here's another thing too, when it comes to making PowerPoints. And you guys have probably been in school long enough to know. Have you seen some bad slides? Give me a characteristic of a poor slide.
Plain and full of.
Say what?
For a poor slide?
Yeah.
Maybe cluttered, or
Yeah.
like bad colors.
So, well, the color, the aesthetic piece, but you guys already hit it. Some of these slides from some of these folks, they're what? There's too much there. They overdo it and translates to clutter. So be sensitive to that. All right, just make it viewer friendly. You can bring some humor in. You might see that along the way.
Can we bring notes to?
Oh yeah, definitely stand up there with notes.
Okay.
Yeah, I mean, and have I seen any? Does anybody here use flashcards? People like flashcards. You know, a nice touch too that, again, you probably like on a presentation is a bullet point, right? So those are just some characteristics there. Just keep your audience in mind. You know, you don't have to get Big Bang Theory on everybody. You know, go over the top. So there should be plenty out there. Any other questions? All right, so I think we're in pretty good shape. The exam next week. What's going on Sunday?
Super Bowl.
Super Bowl is on.
Tampa.